Hello, Alan. So now the range tracker is wired up, so let's see what that looks like. Here we have our GPO, and we will enable and show Crosspol. So if I go from the full state to standby run and click run, we see after 2 seconds of the horn resting at 45 degrees, the Crosspol program starts, and we see as the polarization rotates through Crosspol, the signals more or less disappear. And this is familiar. I've seen this before on A-scopes during trials. That's our GPO. Here's our GPI. And the range gate is fully wired up, so that is a positioning control loop responding to, I believe in the normal way, a split gate tracker. And if we use RGPO and RGPI, it looks like this. Under certain circumstances, you can see the range gate noodling around back and forth, trying to decide which way to go. But anyway. Now, again, the problem is that when you go through Crosspol, all the signals disappear. Now, let's see what it looks like when we wire everything together. So let's put the missile at long range, enable missile flight, and go back to standby run and click run. So now the missile is flying, and we have our initial steal period, and then we go to Crosspol, and then the signals disappear every time you go through Crosspol. Now, normally the seeker would go into a fast range search. I haven't coded that yet, but I will, after it passes through a kind of a coast mode. And again, the problem is the signals are disappearing every time you go through Crosspol. There is a solution to this. If you wire the signals through, or switch the signals through a 45-degree flood horn, and then you put the steal pulses through that, and then when the steal pulse gets within a certain distance of the keeper pulse, switch it to the Crosspol horn. So I've coded that, and this is what it looks like. Essentially what you get is lots of power in the steal pulses and Crosspol happening at the keeper pulses. I think it's interesting. We could use this this could be done with RGPO, for example. The missile's getting closer. And I have coded an attenuation feature so that the power of the steal pulse matches the power of the Crosspol pulse when they get close, before you merge them. So I want to add a little piece here that just illustrates the advantage of having a 45-degree flood horn. So here we have this RGPO waveform. Let's add noise cover pulse and CW noise. And so the waveform is restarted. So now we have the flood horn in play, and Crosspol is happening. If we take the flood horn away, I can switch in between those two cases. Flood horn is gone. Now watch what happens when we go through Crosspol. Everything disappears. But if we put the flood horn in, we get range deception, even if we don't have, or we have the particular part of angle deception happening. Flood horn off, flood horn on, off, on, off. Wait till it fades again. On. And I've added as well a bunch of additional features in the verification panel. You see all these terms. Let's reset the missile to a longer range. You'll see these terms all changing. And there is a way to record the simulation results. So we're recording 2.5, 6, whatever, stop. And then you stop, it tells you created a file and what the format is. And this concludes the demo.